It's my great pleasure to welcome Don Knuth to visit Google today. Don and I were just talking. We met in the mid-1970s, which, you know, he's a very young man. I'm a very old man, but it seems like it's been a while. But Don has done a number of things. He's got a remarkable number of awards. It's hard to say enough about him. I think many people consider him the most prominent living computer scientist. He wanted to come today and have a kind of free-for-all Q&A session, so I hope you all came armed with questions. I think he may be available to sign a book or two after this. I understand a few of you may have brought such things, but let's do that afterwards. But with that, let me welcome Don Knuth.
Hi. Okay, thanks, Bill. I'm not sure if I can match Lady Gaga, but anyway, while I was teaching at Stanford, always last day of class was reserved for all questions answered, and I told everybody they could cut class if they wanted to, but if they had something that they wanted to ask me because they'd paid their tuition and everything, that was the time to do it. And they could ask questions on any subject whatsoever except religion, politics, or the final exam. About 2 years ago at Google, I gave a talk that had something to do with religion, and politics is kind of depressing. But if you want to ask questions about anything, I'll still give it my best shot. But I can probably give better answers to things that I know something about. And I understand that some people have been submitting questions, and they're going to choose the best ones to vote or anything. But anyway, I'm hoping that the questions are not frequently asked questions. Okay, currently in the lead. Okay, so should I mention the guy who asked the question? Does this show up on your table? Whatever. Okay, so let's go. What is the theorem or construct in computer science you feel is most counterintuitive, and which one do you find most beautiful? Okay, well, so this kind of ranking of things in a one-dimensional criterion. On counter, so first of all, we project onto the counterintuitive thing and beauty aspect. Okay, I mean, somehow you ask a parent which of their children they like the best or something. Okay, counterintuitive. Is anything intuitive to me? I guess we go into more and more dimensions. Our intuition seems to be worse and worse. I understand George Danzig once said that our intuition in n dimensions isn't worth a damn. I don't use that kind of language myself, but anyway. So I think the things that we're doing in high dimensional spaces and some of these methods now that are dealing with many degrees of freedom and somehow we can still map them down into something we can control. Those are pretty probably right. The most beautiful theorem in computer science. My goodness. It's always the one. It's the one that I learned most recently. I guess. Yeah, there are a lot of contenders, and then there's this boundary between computer science and mathematics, which is hard to draw. So let's see. Right now, I'm a big. I'm going to go for construct that I find very beautiful because during the last year I've been playing around with a data structure called a ZDD, which isn't the greatest name, but it's the best way that I know to represent families of sets, and families of sets cover many, many applications of all kinds. And it's I played with it. I started out with thinking I would just spend one page of volume 4 talking about ZDDs, and a year later I had almost 100 pages of introduction to it, and I was still learning more stuff about ZDDs. I think it's a very beautiful construction that needs to be studied much more, and soon people will find more reasons for it. Now, let's see, should I alternate between this and people in the audience? Okay, so let's take something from the floor.
Rumor has it there's an amazing pipe organ located somewhere near where you live. Do you ever have any other organists play that pipe organ, and what's your favorite song played on it?
Okay, so yeah, I have. If you look in Art of Computer Programming, Volume 3, in the index under, did everybody hear the question? It's about pipe organs. If you look in the index to Volume 3 under royalties, use of, it'll take you to a page that shows a picture that looks like organ pipe. And so after we had sold a few copies of volumes 1, 2, and 3, I was able to fulfill a dream and get a really nice instrument in one wing of my house. And I guess Alan Kay also has a great organ in his house down in Southern California. My father was an organist, and I took some lessons when I was 12 years old on how to play an organ, and then I was called when I was down in Pasadena as a grad student. I was all of a sudden the organist at the church I was going to had a detached retina, and they called me on Saturday and said, "Don, did you really take a year of organ lessons when you were a teenager? Can you fill in?" And I learned at that time that about all the wonderful literature that's been written for pipe organs, and I found some people down in Pasadena that had gotten an organ in their house, and so that became a dream of mine, and I was able to realize that in the middle 70s, and I investigated. I was thinking maybe I'd get somebody in Denmark to build one for me because they had such beautiful instruments, but that turned out to be impractical because they couldn't give me a fixed price on it. So finally I found a really good builder near UCLA, and they build 4 organs a year, and the one that's in my house is a joy. So we occasionally have people from the American Guild of Organists come for recitals and play on it. And then, like if you're an organist, just see me afterwards, and you can come and try. Stanford students used to practice on it, but there aren't so many organ students now as there used to be.
Thanks. I'll come see you afterward.
Yeah. Now the next one here. What kind of problems do you feel Google or the industry at large should be working on but isn't? Okay, so Google. Okay, well, another great question. I'll just give you one. In Google Maps, put back a facility that I can get the GPS coordinates. I can click on something in Google Map, and then I have a way to find out the GPS coordinates. That used to work last year until November, and it's gone now. And if you Google GPS coordinates in Google Maps, and you'll find a lot of other irate users who miss this feature. So okay. Another one I'll take another one off the screen. Most of the low-hanging fruits in computer science have already been reaped and dissected in detail. Do you still see any of them that surprisingly no one is trying to reap? Okay, so it's true that a lot of things have been dissected in detail, but in all fields, including computer science, it seems that people are always going down the same roads, and it's amazing to me the hit rate of how many times another low-hanging fruit appears in my consciousness, and both in computer science and even in mathematics, which has been around for hundreds of more years, of problems that are very well. Just for example, last year let's see, how do I? I was finishing the 8th volume of my collected papers out of 8, and I got to give a plug for this book because actually I have to admit that I love it much more than I can explain. But it was decided many years ago, more than 20 years ago, that the papers that have been written should be published in archival form with all the bugs removed and adding extra information about the developments since the papers were written and so on. And he divided it into eight topics. The first topic was literate programming, and the second topic was computer science in general for non-specialists, and the third book was about typography and so on. Well, the eighth of these 8 was papers on fun and games, and I saved that up for dessert. It was the one, I knew that if I kept that for last, it would keep me going through all the other papers. And then so here I have this finally. Though I'm closing the door on the papers that I'm writing from now on, I don't write any more papers. I add to the art of computer programming, but I don't. But and I added 17. There are 17 chapters in that book of papers that were never before published, and 2 of those chapters I wrote last year, which you might on topics that you might say are low-hanging fruit, things that research that was still there. In one case, it was about Knight's tours. I call it long and skinny Knight's tours, and I studied the problem of how many ways are there to take a board that has 3 rows and n columns, and find a Knight's tour on this board. And it turned out that it was a really interesting problem, a really challenging problem. It taught me a lot of mathematics as I'm doing it. I can tell you the exact number for any n. I can tell you the asymptotic numbers, and I can classify them into different ways that surprised me. It seemed like low-hanging fruit because you don't need much. I mean, people have been thinking about Knight's tours for 200 years. Still, there was another open problem on Knight's tours, what they call Celtic Knight's tours, which are Knight's tours that are especially beautiful because they don't have 3 lines that come almost touching each other, and so you can make beautiful Celtic knots from the patterns. Anyway, another example of something that was out there. Hadn't been asked. 2 weeks ago, Ron Graham tells me about the following problem: take any integer, write it in binary. So you got basically any sequence of 0s and 1s. You can always cut it, any string of 0s and 1s. You can always cut it into substrings. So that the sum of the consider each substring as a binary number. The sum of those binary numbers is a power of 2. It's not easy, but there it is, and very, in a sense, low-hanging, I would say. Try it out, but don't start thinking about it just before trying to go to sleep. because I was just I was just reading the information. What is it called? The Learning in the Loo or something like this. It tells you how to get a good night's sleep. So. So anyway, surprisingly, there's still a lot of low-hanging fruit, and just keep asking questions. It's not really that likely that it's been totally explored yet. Yeah.
Earlier, you were talking about GPS coordinates, or sorry,
Yeah.
lat longs in Google Maps. There's a labs feature where you can get that on your mouse cursor now.
There's a what?
You can turn on a labs feature.
A labs feature?
Yeah. If you
Okay, well tell me
go to the
afterwards,
settings.
because it used to be that through my maps I could get something called Position Finder, but they discontinued the ability to use other people's Java code during my map.
Well, yeah, I'm not too familiar with what you were using, but if you just want GPS coordinates, you can still get it.
I can do it easily with Google Earth, but with Google Maps I want to be able to do it easy. And I searched, and nobody had published that solution. So that's good.
Well, you can get it with the mouse cursor.
You can get it with what?
It's just the mouse cursor.
A mouse cursor?
Yeah, there's a plugin for it,
A plugin?
or a labs plugin.
A lab plugin. Okay. All right. Well, thank you. With the increase in processing power and adoption of machine-independent high-level languages, it's a common perception that being close to the metal doesn't matter anymore. What impact does this have on computer science as a field of study? I don't like that. I don't agree that it doesn't matter anymore. It doesn't matter as much to as many people as but that's just relative. In absolute numbers, it probably just matters. I mean, we can still use more power. We can still use. There's all kinds of problems where you want to push the envelope and do better, so if you just lots of problems. There's no point in my spending much time on something if it's going to to make to get the answer in a microsecond instead of 10 seconds. So there's no point in it. So I write really inefficient programs to solve certain problems. But boy, when I was studying these 3x(n) Knight Stewarts, I had to find the inverse of a 700 by 700 matrix of polynomials, and so I had to think about it, and I had to know a bit of what's going on. And if people, if imagine a whole generation growing up with this philosophy that you don't need to be close to, you don't need to know anything about the metal underneath, then the programs they write are going to be really bad. So then of course there'll be lots of low-hanging fruit for people who want to make improvements. Okay, next question. Literate programming has never really taken off, although some scripting languages have improved code readability somewhat. What, if anything, do you think has hindered its adoption? Yeah, that's a question that, of course, I can try to answer, but literate programming is so close to my heart that I'm totally biased about it, so you have to discount what I say. Again, in absolute numbers, we've got tens of thousands of people who use literate programs, but still, that's less than 1% probably. I've got at least one program that I wrote that was so complicated that I totally believe that I would never ever have been able to get the program finished at all if I didn't have literate programming to organize my thoughts and make it done. This is This is the meta simulator for my MMix computer. I've got this RISC machine that you can configure in basically infinitely many ways. You can say for each instruction what functional unit it belongs to, how much of a pipeline you want it to have, all kind of caches that you can control, and multiple issue of instructions, and different branch prediction methods, and you can imagine, you can simulate what it would be like if you had a processor with many more things than we know how to build at the moment. But anyway, I wrote this simulator, and it was the hardest challenge that I ever had as far as programming thing. And with literate programming, I was able to finish it in a year, but without literate programming, I think I would have totally flopped. So it's not only, for me, literate programming isn't only nice, it's sort of essential, but it's also nice because I write average of maybe one program a day. Some of them are longer than, some of them are pretty short, but with this literate programming method, it really works for me and makes me happy. Now, on the other hand, fewer than 100% of the world loves it. Now, it's because the way that I read a lot of code, and there's a general and a lot of the best code that I see out there adheres to a certain set of conventions that are pretty good. They're nowhere near as good as literate programming, but still they're good enough that they're adequate. And so and they're understood by a huge community, and so people people know this style, and it's a lingua franca. For me to say drop that and go to literate programming, it was like saying, well, let's go to Esperanto instead of English. Esperanto or some other language that might be even better than Esperanto. Prove that it's a much more logical language. Yet English is good enough, and I'm not going to change from English. So, why should I tell somebody else to change the style of programming that they all can use, and it's good enough. John Bentley might have hit the nail on the head, because the people who like literate programming the best are people who also seem to be the people who also like to write, bloggers and teachers. Because when you're writing a literate programming, you're like in front of a class. You're writing for a human audience rather than for the computer to understand it. You're trying to explain something to another programmer, so there's a certain percentage of the world likes to write, and there's a certain percentage of the world that's good at programming, and you have to be in the intersection of those two in order to really love literate programming. So that might be why it hasn't taken off. Still, I think that if Google managers would sort of say let's have a test here, and we're going to do some system with literate programming, you find that that it might in fact make Google even better than it is now. But anyway, I'm not going to change, and I think a lot of people understand. I can point to some large programs that probably more people understand that these difficult programs than any other programs of their size. So that's my take on that. One more thing though. my book on fun and games, the last chapter of, I don't know how many people know this, but my first publication was in Mad Magazine. And when I was a freshman in college, this article came out, and so now that's chapter 1 of my papers on fun and game. The last chapter is equally crazy, and it's a spoof talk that I gave last summer, where I basically promised that. People were asking about the future of tech, and I said, well, I've decided that everything I did on that project was a mistake, and so I'm starting this. I've secretly started this company, and I've got this new product that's coming out that's not only going to do three-dimensional typesetting, but it's also including the manufacturing on demand, and it also includes things like search engines and social networking, and it solves differential equations, and it's all written in Scheme, and of course we gave up on literate programming because everybody knows documentation is a pain. Okay, so that was the hardest paragraph for me to write. But I thought I needed some kind of bookends to have one. I started out in Mad Magazine, and I had to have something to match it as my final publication. So, okay, Jeff.
So are you using call CC in that program?
Am I using call
CC in your Scheme programs?
Oh,
all right. Here's my question. It's a math search question. So this morning I used social search to find the name of a statistical technique called propensity score matching. And so sometimes I know that there's a mathematical concept that exists, but I don't know what the name of it is, and I want to go find out about it. Integer sequences is a good example of a search technique that allows me to go find,
Yeah, the handbook of the online encyclopedia of integer sequences. You can calculate your way into the literature. If you can compute the first 6 terms of some sequence, you'll find if there's anybody else who's ever been interested in that.
Right.
Yeah.
So that's a good solution. So, but that doesn't solve all problems. So how do you, when you know that there's been a mathematical concept that you've stumbled across, but you don't know the name of it, how do you find out what that name is so you don't have to go reinvent everything?
Okay, well, the answer is, of course, I'm 73 years old now, and I developed a bunch of friends, and so I know, yeah, right. So I know who to ask, but if it's a completely new field, then I haven't got any good method myself. But I often, there's certain questions that I ask Ira Gessel, others I ask Richard Stanley, Herb Wolf, Jeff Ullman, et cetera. Fortunately, I can go down the hall at Stanford and get the answers to most of these questions, and we get together for lunch every week. So that's my solution, but it's not an algorithmic solution at all.
Yeah, you don't scale very well.
I don't what?
You don't scale.
I don't. Well,
I can't replicate you to
Well, in fact, that would be terrible. I mean, if there were, let's face it, if there were 10 people like me in the world, we wouldn't have time to read each other's books. Okay. How many P unequal NP proofs have you seen? What is your opinion on this? P equals or P unequal? When do you think it's going to be settled? Oh boy. Okay. So, I got one last week. And a guy sent me a Java code that seems to prove that P equals NP, I'm pretty sure that he's finding maximum clicks, and I'm pretty sure that that the way he's generating the data is from a set of problems that in polynomial time you'll be able to find maximum clicks. With n cubed steps on the average. So it looks like it would look like p equals np in that, because maximum click is one of those NP complete problems. On the other hand, you've got to be able to solve all problems in a maximum polynomial number of steps in order to have p equal np. Still, his algorithm might be really interesting on practical problems, and so I filed it away to read the code when I get to the point when I'm maybe a year from now, when I'm going to be writing up techniques for maximum clicks. Now, I've done a lifetime share of checking proofs that p equals np or p unequal np. And some years ago I passed that threshold, and so I'll never do it again. But still, there was a pretty serious thing that a lot of people looked at about 6 months ago, wasn't it? And it turned out that it didn't pan out, but still the ideas couldn't be dismissed out of hand. Now, I've also read proofs about squaring a circle too in my youth. Okay, now I have this. To my surprise, I found that I had already given this opinion 15 years ago, but I'm afraid what's going to happen in this question is that that somebody maybe 50 years from now is going to prove that p equals np, and the proof is going to be something like this, that it equals np because there are only finitely many reasons why it couldn't. In other words, a proof that gives us no algorithm. It just proves by that there exists, some exponent, so that, but an algorithm that we'll never know. It's just that it's out there, so then that was the wrong question to ask. It would mean. Now, we already have cases like this. There's some deep theorems in graph theory that say that certain kinds of graphs, in order to test for these graphs, you can do it in polynomial time, but nobody knows the algorithm, because we just know that there's only a finite number of cases to try for, but we don't know what those cases are. We just know that that's not infinite. The paper by Lovas that describes some of the paradoxes coming out of this. So it's looking to me more and more like it's going to be that the number of possible algorithms is huge, and to show that none of those is polynomial time might just be wrong.
Hi. I don't know if this touches more on philosophy, but do you believe that programming is more of an emergent behavior of math, or it's its own thing that just happens to be well described by math?
Okay, the connection between programming and math and emergent from math. I find my own feeling is this, that mathematics and computer science are the two unnatural sciences, the things that are man-made. We get to set up the rules. It doesn't matter the way the universe works. We create our own universes and decide. We can design our computational models, and we can make axioms for mathematical problems. While physicists and chemists and biologists and so on have a different thing. They want to know what's actually in the real world. But are computer science and mathematics really two sides of the same coin, or are they somehow different coins? And I feel strongly that that they're different. But I tried to convince Bill Thurston of this, and he disagreed with me. My opinion, though, is I can feel rather strongly when I'm wearing my mathematician's cloak versus when I'm wearing my computer scientist cap. I'm in one mode or the other sometimes, and sometimes so to me the biggest difference is mathematicians are mostly working on unified theories where you have one or two axioms that are sort of applying all the way through. While computer science, I'm more dealing with very heterogeneous things where there's case 1, case 2, case 3, and we have different things that happen in different states. We have an assignment statement where we can say x is replaced by 2x, so old value of x is gone. Mathematicians, that's a weird concept to mathematicians. So I think of these as different mentalities, different approaches where I can sometimes say, well, as a computer scientist, I got stuck here. Let me try to translate my problem into a mathematical one, and then I think mathematically for a while, and that moves me to another thing, and then mathematically I'm stuck, and then I go back and put on my programming hat again, and try to do something constructive or figure out a data structure that helps me understand the mathematical habit. So I think they're different, but I can't convince Bill Thurston. Now, the other thing that computer scientists, so I can conclude this by saying we got it's pluses and minuses. So there are problems in the world that that mathematicians don't do very well at because they're sort of inherently heterogeneous. Nothing uniform is going to explain them all. And so mathematicians aren't going to be comfortable with that at all. And computer scientists can cut through like butter, knife, But on the other hand, there are problems that that do have a uniform thing, and a computer scientist might not see it because we can find a case 1, case 2, case 3 way to attack it, which is actually very inelegant and missing the underlying unity. So to me, that's the difference.
Thanks.
Yeah. How has your involvement with music affected your computer science and vice versa? I think there's a common thing about patterns, but it's a love of patterns that seems to have a high correlation with the kind of thinking that goes on in both mathematics and computer science. So at Stanford, we had one time the lady who was sort of our department executive head, she had come from the law school, and she said there was an incredible difference coming from the law school to the computer science department in music. The students were interested in music, musicians. It was all completely different than she had experienced in the other school. Anyway, I think there's probably something to that. Although, in the 70s, we used to ask our incoming grad students, the first question was, "What's your instrument?" And we had cases where, I don't know if you remember, Bill, Sam Bent oral exam, he preceded by a cello recital. We would have student parties, and we would do chamber music, and so it was much more in the 70s than in the 80s, because one year I got to the incoming grad students and I said, "What's your instrument?" And it turned out that one guy played a harmonica, and another one said that he did an ABBA imitation. And nobody else did music at all that year. And I said, "Well, what are you? What's your main hobby?" And it turned out that more than half of them were really into bicycle riding. there was a change somehow in the population. I don't understand why, and I don't know what it is now. Anyway, I do believe that that these things go together, but it's maybe not a direct. If I live long enough, I'd like to compose some music with some algorithmic ideas that I have, and so maybe I could influence music that way. How does music actually influence a program that I write? I don't know if I can point to anything direct there. Next question here was, you are famously known for your interest in and contribution to digital typography. Over 30 years after release of tech, what are your thoughts on the current state of typography as it exists on the web and other digital media? And basically, I'm upbeat about the way I got a Nexus S and has beautiful fonts on it. I love the typography that I'm seeing, and I think that people are starting to understand fonts. I guess one of the only predictions that I'm famously bad at predicting. In fact, that's probably one of the fact that I can't predict how hard something is the only reason that I started working on typography in the first place, and art of computer programming and a bunch of other stuff. But I did predict that font designers would become heroes, and that turned out to be fairly close to the mark.
I have a question very similar to one of the previous questions. So now kids are growing up with using computers like on the cell phones everywhere, like the small kids, and but the computers became like really complicated. So what do you think will be the long-term impact? Will we actually have more people understanding how it all works, or we're gonna have actually like a magic, that the only few actually understand?
This is a paradox, and I wish I knew. I just give you a couple of. So I know that my grandkids are pretty fascinated by some applications that you might say are fairly like programming, and they put together objects that and the object can move, and I can't remember the names of the systems that they do. So they're doing more than just passively playing games, although games are I must say I spent hundreds of hours rolling dice when and moving horses along a track when I was in high school. And now the equivalent is doing things on the other hand, Nick Trefethen told me 3 years ago his son is going to the best high school in Oxford, and Nick went there to talk to the kids in his son's school, and he found that not a one of them had ever written a computer program or even thought about it. So anyway, it's a very strange situation that we're in, and you'd think that more. I mean, in the old days, people were learning Logo and Carl the robot and stuff, and now there's many more systems like that, which are quite fascinating. You probably know the one called Chuck from Stanford, and then MIT has this one that was featured in the ACM last year, and there are more. I don't know. I don't know if it'll change. Throughout my career, the number of people out of every 100 people, it's been pretty steady. over my career that two out of every 100 seems to be born to be a computer scientist. You know, they're geeks like me. We have a peculiar way of organizing stuff in our head, and that happens when you're young at some point. I view computer science as something that I do because I just happen to be good at it, not because I had an urge to compute. You know. Now, programming today has not fundamentally changed from programming decades ago. How has the industry failed in this regard, and how could it change in the future? Okay, I wish I could answer about industry, but my own expertise is in writing books, and I don't know how many people have actually cashed the 256 checks. Now, I think some of you know that I reward people for finding errors in my books. And I started that. It used to be $1 back in 1960s, and then it, you know, in the second edition it went up to $2. At some point it switched over to $2.56, which seemed a little bit more appropriate number. I had to, and over the years people used to cash those checks a lot, and it fouled up our checking account. So I got my own, so I got my own account because others were not cashing. Well, now it turns out that the electronic funds transfers is incredibly insecure. The banks have almost no security. The banks believe any electronic message that they get, and crooks have learned how to do this. So that if somebody looks at a check that you write a personal check and has numbers at the bottom, if a crook knows those numbers, he can print himself up an ATM card and withdraw money from your account. Anyway, I had to close 3 accounts because of these numbers were. I mean, I have examples where the check says Bank of America, Atlanta, Georgia, and at the bottom it has the routing number of my checking account in Palo Alto. You know, and people would it looked like a payroll check, and so, you know, $400, cash it at the supermarket. But others were actually, as I say, making ATM cards and doing withdrawals and ordering all kind of fancy computers and stuff. I think probably somewhere in Eastern Europe happening. So anyway, this whole banking system is all screwed up. So about 4 years ago, I started my own bank. And you can find it on the web. It's called the Bank of Sans Serif, and I still write checks, but you don't cash them because it doesn't say pay to the. It says deposit to the account of, and it's a virtual bank. So you can look on there and you can find the names of everybody who's got an account at the Bank of Sans Serif and how much they've done. And I wrote 21 of those checks last month, and I'll write probably 10 this month so far, from what I know, things that came in. Last week I got a letter from China. A guy found an error in volume 1 from 1968. Hadn't been noticed since 1968. Finally somebody read that page carefully. It's true. But it's very valuable to me, you know, trying to make these books more and more correct. What do I think is the most effective way to get children enthused about computer science? I guess we got good tools for them to play with. But I was best at understanding children when I had children who were that age. I mean, when my kids were in first grade, I could design curriculum for first graders, and then the next year I could design curriculum for second graders. Right now, that's wiped out of my head. But I think part of it is they have to have a way to be creative and share their creations with their friends. So that's probably going to be the most effective way. Have some kind of thing where kids can make a construction that they're proud of. Did Steve Jobs tell you he'd read all of your books, and how did you respond? Bye. Okay. Now there's a funny story about that you can look up, and the true story, I believe, is on the Russian version of the Wikipedia, because a guy in Russia wanted to check out the source, and the fact is that I did. I have met Steve several times, and the most likely thing is that he said that I said, "Oh, that's wonderful. You're the first person I ever met who has," or something like that, has read them all. But anyway, I defer the rest of the story. You got a question?
So are you familiar with the field of natural language programming? Or sorry,
Natural language
processing.
Excuse me?
Natural language processing.
Natural language processing. Well, I use Google Translate an awful lot. I know a little bit about the way it works, but
So from what little you know, how do you see it having any effect on the field of literate programming or programming in general?
no. Well, it sounds to me like a different. It's certainly a huge impact on artificial intelligence and a lot of the algorithms that are used in order to deal with things that are okay. To me, I've always looked for a way of getting automatic translation, so that I wouldn't have to use a dictionary, but I only had to learn a dialect of English when I'm dealing with things from other languages, and this seems to be happening now, but I haven't got anything profound to say about it. A friend of mine gave me a wonderful book. They started out with Alice in Wonderland and translated it by machine into French, and then translated that into English and back into French until they had a stable thing, which after 2 cycles you'd get the same thing back again, and then they printed the whole thing in the stable form, and so what is it? So the rabbit is saying, "Oh, precious," instead of "Oh, dear." Yeah. Anyway.
Could I?
Yeah.
I'm going to interject here. I'm going to take the liberty of asking the last question.
Oh, okay.
So, years and years ago, when I was studying computer science, there was a lot more expectation for mathematical training, and I've noticed over the ensuing 30 or 40 years that there's less and less dependence on mathematics, and my impression is that students are less trained in that. I remember it was very controversial at Stanford for a number of years about whether to have an undergraduate degree in computer science and so forth, and I think there was a presumption that people should have mathematics training and so forth before they went into computer science. Do you think how has computer science changed as the role of mathematics has become less in the field? I'd be interested in your view.
Yeah. Okay. Another great question. In fact, all of these questions have been really terrific. There's a lot of computer science, of good computer science that can be done without a lot of mathematics now. But there's just as many examples of really cutting edge mathematics going into computer science as well. I mean, I just go through our building and you know, the computer graphics, all the rendering methods that are heavily based on mathematics, and you know, the new camera techniques are incredible. People are using high mathematics in artificial intelligence, all of the Bayesian network, the calculations with robotics are requiring great mathematics. You know, all of our I don't think, however, that I need a terrific amount of mathematics to come up with Facebook. But still, I understand the way Facebook is able to do its magic is by actually putting everybody's Facebook page in one giant computer somewhere. And anyway, and there's certain mathematic knowledge in order to understand caching and but not traditional mathematics. So mathematical paradigms are still there. You have to know the concepts of rigorous proof for at least half of computer science now, I would say. But there's also lots of other things that are when we talk about design of GUIs or something like that, where you don't need so many theorems.
Now that's true, but I've heard a few people say that reading your books, the art of computer programming, is challenging if you don't have the right mathematics background, which I think is true. But
yeah, no, it's not easy to read my books, but it could be a lot harder. I try to make them as simple as possible, but I haven't succeeded in making them a breeze.
So with that, I want to thank Don again for coming by and answering questions, and thank you for providing questions. Thanks again.